Hi, fourth grade. Welcome to Tuesday Math. Today we are going to talk about drawing parallel and perpendicular lines. Now, once again, we talked about this a little bit before we left school, so I want to go in more detail. We are on page 879. Please get your book out and we'll take a look at that. So remember we talked about lines, rays, and line segments. This says you can describe lines, rays, and line segments by the way they cross each other or do not cross each other. So that is what this is all about, by the way they cross each other or do not cross each other. So let's take a look at this. Oliver was riding in the car and saw this sign. Describe how the outlined line segments cross each other or do not cross each other. So they're looking at the sign, you see, kangaroo crossing, nothing we see around here. You've got a line here and a line here. Now, if you extended them, they would never cross each other. They're called parallel lines. Parallel lines are always the same distance apart. They do not meet or cross each other. So Oliver saw a figure with parallel line segments. And I like writing parallel because in the middle there are parallel L's. That's a good way to remember it. Excuse me. So, key concept, types of lines. The first one, parallel. Parallel lines are always the same distance apart. They do not meet. So these are two parallel lines. I want you to look around your house for a minute, see if you can find some parallel lines. Now take a look. It says line AB is parallel to line CD. So the way you show that is you write line AB. Remember how we did that? And then you write line CD, remember how we did that? And then you put these two little parallel lines in between. The symbol, two little parallel lines, means parallel. So you would read this, line AB is parallel to line CD. Well, what if they cross? Now we're on page 880. If they cross, we say that they're called intersecting lines. Intersecting means they cross somewhere. So we'd say line AB intersects line CD, or the symbol for line AB intersects line CD. There is no cool little symbol for intersects, unfortunately. You have to write it out. Now there's a special type of intersecting lines that form square corners. Lines that meet or cross each other to form square corners are called perpendicular lines. Say perpendicular. And that's when two lines intersect, but they form a square corner. This symbol here means square corner or right angle, which you're going to learn. So this says line AB is perpendicular to line CD. And there's this cool little symbol, which is a perpendicular line, to show that line AB is perpendicular to line CD. So now let's take a look at the question on example 2. Describe the figure, use parallel, perpendicular, intersecting, use the most specific term. So take a look over here. Well, do they cross each other? Yes. So they are intersecting for sure. Do they form a corner, a right angle? No, they don't. So they're not perpendicular, they are just intersecting. But take a look here. It says, describe the line segments outlined on the tennis racket. Now, there are no letters here. You just have to write what they are. Are they parallel, intersecting, or perpendicular? Write the word here. Did you write parallel? Well, then you would be correct. They are parallel lines. They never cross. All right, you are going to do page 881 and turn it in. And this has several sections. The first one is identifying what they are. You're going to use the words parallel, perpendicular, or intersecting. For this one, you are going to draw examples. So here it says, I'll do the first one with you. DE is what? Parallel to FG. So remember how you drew a line. There's a line. Here are points D and E. Now you're going to draw another line, and it has to be parallel. So you're going to draw another line underneath that and label it F and G. So now you have line DE is parallel to FG. Over here it says intersects. Over here it says is perpendicular to. Now here's another one that is parallel, but notice this is a what? A line segment, and this is a ray. And then for the last part, you're going to look at this and figure out which one of these statements is true about this figure. Okay, so that's 81. Let's take a look at this map. We're going to do this together for just a minute. On a map, streets can be represented by line segments. Use the map to answer exercises 9 through 11. It says, identify 2 streets that appear to be parallel to Washington Avenue. So you look at this map. Here is Washington Avenue. Now, can you find 2 streets that are parallel to that? I want you to stop the video and write it down. Okay, did you write Liberty Street? Well, good, because that's not really right. They wanted parallel lines. So here's Washington. Where's another parallel line? Hayes. Here's Jefferson. So you should have written over here, Hayes and Jefferson. Now, what about Lincoln Street? Lincoln Street looks pretty good. But it's not parallel because it breaks off and it does not continue all along here. It goes off like that. So that is not parallel. Then it says, tell whether Hayes Avenue and Capitol Lane appear to be parallel, intersecting, or perpendicular. Let's look over here. Here's Hayes Avenue, right? And here is Capitol Lane. Well, they're not perpendicular, right? Because they're intersecting. But then, what do you think? Does that look like a square corner? It does. So what are you going to write here? Go ahead. Did you write perpendicular? Then you would have been right. They are perpendicular. Then it says, are there any streets that are intersecting but not perpendicular? Explain. Well, we just did that, didn't we? Because over here we said Washington Avenue and Lincoln Street are not parallel because they are not always the same distance apart. So here's another interesting part. Tell whether each statement is true or false. If 2 lines are parallel, they are always the same distance apart. True or false? Go ahead and write that. Did you write true? Well, then you would have been correct. Let's look at the next one. If 2 lines are parallel, they are also perpendicular. True or false? Go ahead and write that. Did you write false? Yes, that is false because a line cannot be parallel and perpendicular. Those are actually opposites. All right, on page 883, there's a great review here which you can read. It shows parallel, it shows perpendicular, and it shows intersecting. And this shows some things around the house or around your world that are parallel. So for instance, railroad tracks are parallel, but they're also parallel that way. A fence that goes like this, and these would be perpendicular, but these lines are parallel to each other. All right, take a look, one more together. It says, describe the figure. Use parallel, perpendicular, or intersecting, the most specific term. So write your answer. Sorry, that's blurry. I'm not quite sure why that's all blurry. All right, what did you write? Did you write perpendicular? Then you were correct. All right, good. So now you're going to do page 884 and turn that in. Have a great afternoon, great morning, great day, and do well in your math. God bless you.